Hi everyone, happy Wednesday. Your last bit of material that we are going to cover for this unit is on factored form. And before we move forward with the lesson, I do have some unfortunate news to share with you. Last night we found out that my son was identified as a close contact for someone in his junior kindergarten class that had tested positive. So he has to stay home for the next 2 weeks. And likewise, because of my obvious close contact to my son, I also have to stay home and isolate for the next 2 weeks. So you are not going to be seeing me until the new year, unless something drastic happens. Now, if you're worried, so far everyone's okay, no one has any symptoms or anything, but we do have to isolate according to the health unit. Now, don't worry about the lessons because you're in good hands with Mr. Hack. He can answer any of your questions. Plus, I'm going to give you a video lesson for every single lesson that we do. So you're still going to hear me. You're still going to be able to hear how I explain things. And while I know it's not optimal, like face-to-face would be, you still can listen, fast forward, rewind, hit pause, go back, copy things down at your own pace. And Mr. Hack has all of my lessons. He has all of my tests. I've sent them to him. So all the material you would have got from me, you're still going to get that. And don't forget, too, that not only do you have Mr. Hack, but you can send me a message on Hasia, or you could send me an email, or you could post something in the D2L homework forum. So you have lots of different ways where you could ask myself or Mr. Hack questions to make sure that you keep up your success. And remember, we've kind of already gone through the lion's share of the hard units, especially from this second one. And then moving forward on Thursday after your test, when we go into the next unit, hopefully it should start to be mark boosting for you. And it's not that bad. But remember, you do have lots of options to get in contact with me and make sure that you end up being successful over the next 4 classes that I'm going to end up missing. So with that being said, we are going to soldier on here with factored form. We are going to connect it to one of the forms of a quadratic equation, and then we're going to take a look at how that relates to the zeros. So our final form is factored form. And I've mentioned it a couple times, but we haven't formally done anything with it, or at least I haven't formally referred to it until now. So we've done vertex form, we've done standard form. The third and final form is factored form, which looks like this. Y equals A, x minus r, and x minus s. And we've kind of done stuff with this. We started out by expanding, and you're just like factored form looks like this, and you expand it to get to standard form. This A value, we've seen that pop up already a couple of times. It's out front in your vertex form, it's out front in your standard form. All of those things are exactly the same A value. So, same A value as before. Which, remember, it controls whether your parabola opens up, whether it opens down, whether it's stretched, or whether it's compressed. We care about vertex form because it gives you the vertex. We care about standard form because it gives you the y-intercept. We care about factored form because it gives you the zeros. And your zeros are x equals r and x equals s. And those are your zeros. And basically, it's what makes each bracket 0. So we're going to build off of factoring. We're going to factor and we're going to state the zeros. So that's the only new part. For factoring, you might want to refer to yesterday's lesson or have it handy in front of you to be able to know what type of factoring to do. So the first one, x squared minus 1. Always check for a greatest common factor first. Don't have one other than 1. The next thing, is there 3 terms, a squared, a plain x, and a number? No. So we know we're not doing box method. So for this one, there are 2 terms, and they're separated by a minus, and they both have nice square roots. So this is a difference of squares. So this factors 2. So recall from yesterday. 1 is positive. 1 is negative. What's the square root of x squared? X and x. So remember we're doing this. What's the square root of 1? 1. So we have x plus 1 and x minus 1. And that's from yesterday. Now the new part, state the zeros. Remember, zeros is just another word for x-intercepts. So you want to know what makes each bracket 0. What value of x? So you're asking yourself, what plus 1 for the first bracket gives you 0? So you could do trial and error, I guess. Say x is 0. 0 plus 1 is 1. That's not 0. Say x is 2. 2 plus 1 is 3. That's not 0. What is the only thing that will make that first bracket 0? What plus 1 gives you 0? Hopefully you're thinking x equals negative 1. Negative 1 plus 1 gives you 0. The next bracket, what minus 1 gives you 0? Hopefully you're thinking positive 1. 1 minus 1 gives you 0. And those are your 2 zeros or your 2 x-intercepts. The next one, check for a greatest common factor. There isn't one other than 1. Is there 3 terms? Yes, a squared, an x, and a plain number. So that is a trinomial, so we're going to use the window or box method. And if you're someone who can do this quickly, then you don't have to worry about this. Don't forget, ax squared goes there, so x squared, and then minus 3, and then minus 2x. X times x gives you x squared, and then what 2 numbers multiply to 3? 3 and 1, which is 3x and 1x. And how do I get negative 2 out of that? That's got to be negative 3. That's got to be negative 3. And that gives me negative 2. So my factors are x plus 1 and x minus 3. Now you got to state your zeros. What plus 1 is 0? Negative 1. Negative 1 plus 1 is 0. What minus 3 is 0? 3. 3 minus 3 is 0. So there are our zeros. Our next two, factor, state the zeros. Are there 3 terms? No. Are there 2? Yes. Are they minus? No. So it's not difference of squares, but we forgot to check for a common factor. So what's common to both of those? So we got x squared plus 8x. So looking for a common factor, what's common to both those terms? No number other than 1. However, they both have an x. Do they both have x squared? No. So we can take out an x. Don't forget that goes out front. That leaves you x squared divided by x, leaves you with x plus 8. Now we got to state our zeros. I'm going to start with the one on the right. What plus 8 is 0? That's negative 8. So x equals negative 8. The one on the left, that's the one that's often confusing because you don't see it with a number. If you don't see it with a number, really, we're not going to write that in, but we could as like an aside here. We don't see anything there. We could write it as x plus 0. So you'd be asking yourself, what plus 0 is 0? You could say 1. 1 plus 0 is 1. That's not going to work. Negative 1 plus 0, that's negative 1. That's not going to work. What plus 0 gives you 0? The only answer to that is 0. So x equals 0. As a general rule of thumb to keep in your back pocket, whenever you see a plain x, when there's nothing else in brackets, your 0 is always going to be 0. The only thing you can sub in for that x to make it 0 is 0. Let's try the next one. 3 terms, x squared, x plane number. That means box window method. X squared goes there, negative 15 goes there, 2x goes there. What multiplies to x squared? X and x. What multiplies to 15? 5 and 3. So that gives you 5x and 3x. How do I get 2 out of that? 5 minus 3, and if that's negative, that's got to be negative. And then double check, make sure negative 3 times 5 gives you negative 15, which it does. So our factored form, x minus 3, x plus 5, and then to state your zeros, what minus 3 is 0? X equals 3, right? 3 minus 3 gives you 0. What plus 5 is 0? Negative 5, right? Negative 5 plus 5 gives you 0. Hopefully that's starting to make sense. So nothing's new other than the zeros. It's still just factoring work. Now the last kind of example we are going to do, you're going to see this pop up again on your review. You might also see this pop up somewhere important later on. So we know how to graph from vertex form. It's pretty easy. Put your vertex on, use your step pattern. Now we're going to look at something that has more steps, which is to graph something in standard form. So we can't just read off the vertex and use the step pattern. So I've laid out the steps here in order. So step number 1, factor. So this has 3 terms. Check for a common factor. Other than 1, there isn't. So x squared, 5 goes there, negative 6 goes there. What multiplies to x squared? X and x. This one's pretty easy. What multiplies to 5? 5 and 1. Multiply across. 5 plus 1 is 6, not negative 6. But what that means is that both these have to be negative, because negative 5 minus 1 is negative 6. And if both those are negative, then those are negative. Double check. Is negative 5 times negative 1 positive 5? Yes, it is. So our final factored form, x minus 1 and x minus 5. Our zeros, what will make the first bracket 0? What minus 1 is 0? Well, that's 1. And from the second bracket, what minus 5 is 0? 5. 5 minus 5 is 0. The next thing you do is plot the y-intercept or identify with the y-intercept. Do not forget, when it's in standard form, your y-intercept is this last number. So my y-intercept is 0 and 5. Step number 4. Find the axis of symmetry. Now, if you remember from that one summary sheet we made of standard form, there's actually a way to find the axis of symmetry from your equation. And the axis of symmetry, if you look back at that sheet, equals negative b over 2a. Do not forget your b is your middle term. So that equals, now negative times, we'll just go through all these steps, negative times negative 6, and your a value is out from, which is just 1. So 2 times 1. Two negatives up top make a positive, so that's positive 6. 2 times 1 is 2, which that equals 3. So your axis of symmetry is x equals 3. Another way to think about this, if you don't want to use that equation, remember that your axis of symmetry is always halfway between your zeros. And if we look back at one of our previous steps, step number 2, our zeros were at 1, 2, 3, 4, 5. We had a 0 at 1 and 5. What's halfway? So remember, your axis of symmetry always cuts your graph in half. What's halfway between 1 and 5? 3. You could use your fingers, work your way into the middle, or just know by looking at that 3 is in the middle. Find the optimal value. Your optimal value is wherever your axis of symmetry is. So we're going to put 3 in for x. So wherever I see x, I'm going to put in 3. So 3 squared minus 6 times 3 plus 5. You can enter that into your calculator just like you see it. And hopefully when you do that, you get negative 4. Your vertex. Your vertex just comes from step 4 and step 5. So your axis of symmetry is your x value, which is 3. And your y coordinate of your vertex is your optimal value, which is negative 4. We use all of those plus our step pattern to make a smooth curve for the parabola. Your 3 magic numbers, 1, 3, 5, and you multiply by your a value, which in this case is 1. So we're left with 1 times 1 is 1, 3 times 1 is 3, 5 times 1 is 5. Our step pattern is as it normally would be. So we're going to take all those things and we're going to plot our parabola. So at this point, if you want to take a quick minute, pause it, make your x-axis, your y-axis, put those numbers on, you can. And when you come back, you can follow along with the graph. So step number 2, plot your zeros. We got zeros, which are fancy words for x-intercepts, at 1 and 5. My y-intercept was 5, the last number of your equation. Remember, our axis of symmetry was 3. We don't have to put this in, but let's just do it. That's the dashed line that cuts your graph in half. Your optimal value is negative 4, and that's on that dashed line. Our vertex was 3, negative 4, so 3, negative 4 is right there. And that's all we got from the steps. But we know using our step pattern. So our step pattern was, remember, 1, 3, 5 after we multiplied by the a value. So from your vertex, over 1, up 1 on both sides. Over 1, up 3, 1, 2, 3. Now that's a built-in self-check. If we went over 1 and up 3 and we didn't hit that x-intercept, we know we made a mistake. Over 1, up 5. Again, we already have that point on there on the left, over 1, up 5 on this side. And we can stop there. Connect them all with a smooth parabola. And then don't forget to put your equation on. Y equals x squared minus 6x plus 5. So there are a few steps to that. Again, we'll do it again on the review, and you'll get some chance to practice this later on. And again, make sure you know how to do a question like this. And it'll be scaffolded on, if it does appear on a test, it'll be scaffolded on your test, labeling the steps to do. You just have to know how to do them. Now, the last thing I want to talk about are achievement checks. Since I'm not going to be there, you are not going to be handing in your achievement checks because I can't expect Mr. Hack to mark them quickly and then hand them back to you. So unfortunately for your unit test coming up on Thursday, so tomorrow, and your unit test on Monday, there's only going to be one thing that I enter for your marks, and that's going to be the test. However, I would say don't neglect the achievement checks. Still do them. So for this achievement check right here, I would do it, and if you want, you can ask Mr. Hack if you got them right, or you could take a picture and send it to me in Hasia, and I'll take a look at your solutions, and I'll get back to you and say, yep, that looks good, no, let's change this. That's probably a good thing to do, I would say. So I wouldn't just outright neglect them, I would still do them as extra practice, and then ask myself or ask Mr. Hack to take a look at them. So that would have been the first achievement check for this lesson, so just factor and state the zeros. And this one had a second achievement check, which was graph the equation below by following all the steps that we did in class. So for the last example, those 7 steps we did, write them all down and do this equation, do this one just like we did. And for this one, again, I give you a hint. Don't forget to check for a greatest common factor first. So when you go to factor it, check for the common factor first before you state your zeros and go through the rest of the process. Once you're done that, you can work on workbook section 2.9. And then you'll be tuning in later today for your second video lesson of the day. Have a great morning. Talk to you soon.